Imagine you're building a magnificent house. You wouldn't wait until the entire structure is complete to check if the foundation is solid, would you? The same principle applies to software development. Just as a builder inspects the foundation, software developers use smoke tests to ensure the stability of their code from the very beginning. Smoke tests are like a quick health check for your software. They are a subset of tests designed to quickly assess the basic functionality of a system. Think of them as a series of preliminary checks to make sure the most critical parts of your software are working as expected. These tests are not meant to be exhaustive or to cover every possible scenario. Instead, they focus on the core features of the application, ensuring that the most important functions are operational. Like a puff of smoke that signals a fire, a failed smoke test immediately alerts developers to critical issues. In essence, smoke tests act as an early warning system, helping to detect and resolve major problems early in the development cycle, saving time, effort, and resources in the long run. Smoke testing is a crucial aspect of software development that focuses on verifying the stability of a software build before it proceeds to further testing stages. It's like a quick checkup to ensure that the most critical functions of the software are working as intended. The primary goal of smoke testing is to identify any showstopper defects early in the development process. These are critical issues that would prevent the software from functioning properly and block further testing efforts. By catching these issues early on, developers can avoid wasting time and effort on a build that is fundamentally flawed. Smoke tests are typically run after every new build of the software is created. This ensures that any recent code changes haven't introduced any major regressions or broken existing functionality. The tests themselves are designed to be quick and efficient, providing rapid feedback to the development team. The results of a smoke test are either a pass or fail. A pass indicates that the core functionality of the software is intact, and the build is stable enough for further testing. A fail, on the other hand, signals a critical issue that needs to be addressed immediately before any further development or testing can proceed. To harness the full potential of smoke tests, it's essential to design them with specific criteria in mind. Effective smoke tests share common characteristics that contribute to their efficiency and effectiveness in identifying critical issues. First and foremost, smoke tests should be fast. They need to provide rapid feedback to the development team, so they should ideally execute within a few minutes. This ensures that developers receive prompt alerts about potential issues without delaying the development process. Secondly, smoke tests should be reliable and consistent in their results. They should produce the same outcome every time they are run, given that the software under test hasn't changed. Inconsistent results can lead to confusion and wasted time investigating false positives. Coverage is another crucial aspect of effective smoke tests. They should cover the most critical functionalities of the application, ensuring that the essential components are working as expected. This doesn't mean testing every single feature, but focusing on the core aspects that are crucial for the software to function. Finally, smoke tests should be easy to implement and maintain. They should be straightforward to set up and execute, even for team members who may not be deeply involved in testing. This ensures that smoke testing can be integrated seamlessly into the development workflow. Implementing smoke tests as an integral part of the software development process brings numerous benefits, improving the overall quality and efficiency of the development cycle. One of the most significant advantages is the early detection of defects. By identifying and addressing critical issues early on, smoke tests help prevent these issues from propagating to later stages of development, where they become more complex and costly to fix. This early detection also leads to faster feedback loops. Developers receive immediate notification of any issues, allowing them to address them while the code is still fresh in their minds. This rapid feedback loop accelerates the debugging process and reduces the time it takes to deliver a stable build. Moreover, smoke tests contribute to reduced development costs. By catching defects early, they prevent wasted time and effort that would be spent on developing and testing a build that is fundamentally flawed. This streamlined approach optimizes resource allocation and contributes to cost savings. Furthermore, smoke tests improve the overall quality of the software. By ensuring that the core functionalities are always in working order, smoke tests provide a safety net that allows developers to confidently build upon a stable foundation. This iterative process of testing and improvement leads to a higher quality end product. Section 5. Smoke tests in action, real-world examples. Let's consider a real-world example to illustrate the benefits of smoke testing. Imagine a team developing an e-commerce website. A smoke test might involve simple checks like verifying the homepage loads, browsing categories, and adding items to the cart. These tests quickly identify major issues. For instance, if the homepage fails to load, it signals a critical issue. Similarly, for a mobile banking app, smoke tests might include checking the app launch, login, and basic transactions. These tests ensure core features are functional. Section 6. Implementing smoke tests. Getting started. Implementing smoke tests is straightforward and integrates easily into the workflow. Define the scope, select tools, and establish a routine. Identify critical functionalities to cover. Focus on core aspects crucial for basic functionality. Choose the right testing tools. Create simple, concise tests. Establish a routine for running tests. Run smoke tests after every new build. Section 7. Automating smoke tests, streamlining the process. While smoke tests can be executed manually, automating them offers significant advantages in terms of efficiency and reliability. Automated smoke tests can be integrated into the build process, ensuring that they are run consistently and provide rapid feedback to the development team. Automating smoke tests involves using a testing framework or tool that can execute the tests without manual intervention. These tools typically provide features for writing test scripts, running tests, and reporting results. The choice of tool depends on factors such as the technology stack, budget, and the team's expertise. Once the automation framework is set up, the smoke tests are scripted using a scripting language supported by the chosen tool. The scripts define the steps involved in each test, such as navigating to specific pages, entering data, clicking buttons, and verifying expected outcomes. Once the tests are scripted, they can be integrated into the build process. This means that whenever a new build of the software is created, the automated smoke tests are triggered automatically, and the results are reported back to the team. Automating smoke tests not only saves time and effort, but also enforces consistency in testing. Automated tests are executed the same way every time, eliminating the risk of human error and ensuring that the results are reliable and repeatable. Section 8. Common pitfalls to avoid, navigating the challenges. While smoke testing offers numerous benefits, there are common pitfalls that teams should be aware of to ensure its effectiveness and prevent wasted effort. One common mistake is creating smoke tests that are too comprehensive. Remember that smoke tests are meant to be quick checks, not full-blown regression tests. Focus on testing the most critical paths and functionalities to avoid unnecessarily long execution times. Another pitfall is neglecting to update smoke tests regularly. As the software evolves, so should the smoke tests. Ensure that the tests are updated to reflect new features, functionalities, and changes in the application's behavior. Ignoring test failures is another mistake that can undermine the effectiveness of smoke testing. A failed smoke test is a red flag that indicates a potentially serious issue. It's essential to address failed tests promptly and not dismiss them as insignificant. Lastly, relying solely on smoke tests is not advisable. While smoke tests are valuable for early detection, they are not a replacement for comprehensive testing. Combine smoke tests with other testing methods such as integration testing, regression testing, and user acceptance testing to ensure the overall quality of the software. Section 9. Conclusion. Embracing smoke tests for software excellence. In today's fast-paced software development landscape, delivering high-quality software quickly and efficiently is paramount. Smoke tests have emerged as an indispensable practice for achieving this goal, providing a safety net that allows developers to build upon a stable foundation and deliver exceptional software. By incorporating smoke tests into your development process, you gain the ability to detect critical issues early, accelerate feedback loops, reduce development costs, and ultimately deliver a higher quality product. Embrace the power of smoke tests and witness the positive impact they have on your software development lifecycle. As you embark on your software development journey, remember that building great software is an iterative process. Smoke tests are not a one-time activity but an ongoing practice that should be integrated throughout the development lifecycle. By consistently applying the principles of smoke testing, you can ensure that your software is always on solid ground, ready to meet the demands of your users.